Hello friends, today we discuss about contiguous of a function at a given point. So now let us see a test for a given functions to continuity at a point by ES definitions, that is epsilon, and this is delta definitions. Suppose a given function is fx and which is equal to x square sine 1 upon x, and these functions is whenever x is equal to 0, and fx will be 0 whenever x will be 0. Then when x is 0, functions will be 0. When x is not is equal to 0, then function is defined as x square into sine 1 upon x. Now, in this method, first of all we have to take the situations. Absolute values, that is modulus fx minus f0. So what is the fx? Fx, that means when x is not 0 or the nearest point of x is equal to 0. So now fx will be, this is when x not is equal to 0, then graph or function is x square sine 1 upon x, this is x square sine 1 upon x, minus f0 is given is 0. This is the magnitude. Now it will be is equal to mod of x square into sine 1 upon x. So this is equal to, by the properties of mod is distributed in two terms of multiplication. So in x square, also in sine 1 upon x, the magnitude. Now as we know, sine is a periodic functions whose range is always from -1 to +1. So absolute values of sine is always less than or is equal to 1. So finally we conclude that fx minus f0 is less than or is equal to x square. Since this is x square, so no mean of mod, only x square. Now that is, we conclude fx minus f0 is less than or is equal to x square. Now the main concept behind here, when mod of x minus 0 will be less than delta, or simply when mod of x is less than delta, this implies that mod of x square is less than del square. So considering the equation number first. So for arbitrary positive epsilon, now these two you have to understand. For arbitrary positive epsilon, however small, that is, we choose or a given epsilon, for arbitrary positive epsilon, however small, any types of epsilons, if we choose, definitely we can choose a del such that del square is less than epsilon. That is, for any arbitrary epsilon we can choose a del. For any type of epsilons we can choose a del, and now fx minus f0 is less than del square is less than epsilon. So finally we conclude fx minus f0 is less than epsilon. This is equation number 2. Hence function of x will be contiguous at x is equal to 0. So whenever there an arbitrary epsilon, we can choose a del. So for any type of epsilon, if we can choose a del, then the functions like that, and we can say the function is continuous. Or in other words, here, in other words, we can say a function is contiguous at a point A if for given epsilon, if an arbitrary epsilon which is given, then there exists, the point should be quoted. For a given epsilon positive, there exists a del positive. For a given epsilon, then there exists a del positive such that x minus a is less than del implies that fx minus fa is less than epsilon. So now we recall again, for a given epsilon positive, there exists a del. So del is depends on epsilon. For any epsilon, there exists a del for any types of epsilon, such that whenever mod of x minus a is less than del implies that mod of fx minus fa less than del. So any type of functions will be contiguous whenever follow this rule. So thank you. This is the concept of epsilon delta definitions for being a contiguous functions.